This is Josh White with JW Math Tutoring. Today's video is going to focus on the 6 hardest questions from the June 2022 ACT Math Exam Form E26. So again, these are just 6 questions that I specifically pulled out from this exam, and I'm going to go through and demonstrate how to solve each of them. Just a couple things to keep in mind. Obviously, if you like this video and like my other videos, please do click the thumbs up button on it, and also subscribe to my channel, sign up to receive notifications. And in addition to that, if you are looking for assistance with the math section of the ACT, please do check out my Improve Your ACT Math Score course. It's available on both Teachable and Udemy, covering a wide variety of topics in ACT math, reviewing algebra, geometry, probability and statistics, and other topics, as well as how to use the graphing calculator to solve problems and techniques like back solving and picking numbers. All right, so with that said, let's go ahead and get started with this video.
But life is a dream the calculus could never predict.
All right, one quick thing I want to mention just before I go ahead and show you the solutions to these 6 problems that I've chosen. So the reason that I'm only having 6 problems in this video is because I had previously uploaded the full solutions to the June 2022 ACT math section, but they were taken down because of a copyright notice from the ACT. So per what they told me in the email they sent me, they're not targeting individuals that are discussing like 10% or less of content from a specific exam on YouTube. So that's why I'm only choosing 6 problems from this exam to highlight, which works out to 10% of the 60 total problems. So the 6 problems I'm going to go over are problems number 40, 45, 52, 53, 56, and 60. And so you'll see the full solutions to those coming up, which again I thought were 6 of the most difficult or trickiest or hardest problems on this exam. The next problem, number 40 here, is one of the trickier questions on the test, but basically what you have to do is just kind of use brute force or trial and error, just kind of go through the answer choices and work it out and see which one actually makes sense. So if you start with the first possible answer choice, which is letter F, which is say Tuesday. Okay, so let's just say I'm going to put Tuesday, Wednesday, Thursday, Friday, whatever, Saturday, Sunday here. We'll put Monday in front. Okay, if Tuesday is the first of the month, then what happens is it would make Friday into second, third, the 4th of the month, and then it would make Monday into the 7th of the month. So now you could go ahead and you could fill in. So for example, the next Friday would be the 11th, then after that we would have the 18th, then we'd have the 25th. Now if you added 7 more days, you would get 32, but there are only 31 days in July, which is the most number of days in any month. So therefore, there are only going to be 4 Fridays in the month of July if the first of that month is on a Tuesday. So that part basically checks out. Now let's examine Mondays. So we could have the first Monday being a 7th, then the next one be a 14, then a 21, then a 28, and then again if you add 7 more days you would get 35, but that's past the 31 days. So the correct answer for this problem is going to be letter F, Tuesday. Now, here's what happens if you try the other days out, just to show you why there's either not 4 Mondays or not 4 Fridays. So if we look at the second answer choice, which is the first on a Wednesday, okay, so basically move everything over now. And previously Friday was the 4th, but now it would turn out to be the 3rd. So then we would have the 10th, we would have the 17th, we would have the 24th, and notice what happens now. When you add 7 days, you get 31, which is an acceptable day in July because there are 31 days. So for this answer, you would not have only 4 Fridays, you would have 5 Fridays, so that's why it's eliminated. If you check the next one and you actually moved the first over to Thursday, what you will notice is that the dates for all of the Fridays are basically now just going to go down by one, because instead of being the 3rd, it's going to be the 2nd, and then the 10th would go to the 9th, and the 17th would go to the 16th, and the 24th would go to the 23rd, and 31st would go to 30th. So that one's not going to work either. Now, for the last remaining answer choices for Saturday and Sunday, basically the same pattern happens on a Monday, and that's what eliminates them. So what I mean by that is if the first of the month is on a Saturday, okay, then what ends up happening is the Saturday here is the first of the month. Sunday's the second, and Monday turns out to be the third. And then notice you get the exact same dates on Mondays right here, where it's going to be 3, 10, 17, 24, 31. So there's going to be 5 Mondays, not 4, and that would eliminate it. And then similarly, if you move the first now over to Sunday, then for the Mondays, okay, so it's not going to be the 3rd for the first Monday, it's going to be the 2nd, and then you'll get the exact same values that we just saw over here, where it's going to be 2, 9, 16, 23, 30. And so there would be 5 Mondays, not 4, and that's basically what eliminates that answer choice. So this one you just kind of have to write it out, basically go through the answer choices. Essentially it's back solving, but go through the answer choices, write it out, and then just determine which one meets, both the criteria with only 4 Mondays and 4 Fridays. So correct answer is letter F. Okay, below that we have problem number 45. This again is another one of the tricky problems on the test that you pretty much just have to do by kind of like trial and error or brute force, meaning go through all the answer choices and try, drawing them out and seeing which one you can basically get to work. So I will tell you the answer is going to be letter E right here. There are technically multiple ways you can do it, but essentially it's going to be some combination of the following. So the way that I did it is I started at Ripley, then I went to Portville. So like this is whatever, like track 1, then track 2, and then I went back to Ripley here, track 3. And then I went down over here to Marcus, track 4. Then I go down here to Willa, track 5. Then I go down here back to Baytown, track 6, and then I go down back to Willa, track 7. Now, you could do variations here, meaning you, like for my first thing, you could switch the order you go in. You could go Ripley to Baytown, then to Portville, then back to Ripley. Or, again, the same thing here. You could go Ripley to Marcus, then to Willa, then down to Baytown, then back to Willa. So you can flip and change some of these different iterations of the mail run, but this is basically the only correct answer. This is the only way essentially to do it, to start at one thing and end at another thing without only going over through each road, one time. Next up we have problem number 52. So for this one, basically the easy way to do this is to like start kind of working through the answer choices or back solving it by keeping in mind that if you take the ratio between these and say multiply them, take these two numbers and each multiply them by x, and then add it up, it has to equal 54 because there's 54 total hamsters. So if you start with answer choice F, the ratio here is 1 to 54, so I'd say like 1x plus 54x, and then that would be equal to the total number of hamsters. But for this one, it wouldn't work out because you'd get 55x equals 54, x equals, some fraction. And notice that like if there was one solid color and 54 multicolored, that would mean that you had a total of 55 hamsters, which is more than you even have in the store. So that one like just doesn't make sense logistically to right away off the bat. But now we're going through the others. So if you check the second one, so 2x plus 7x equals 54. And you get 9x equals 54, x equals 6. And the whole key is that you're looking for the one answer choice where the value for x, which is like your multiplier, is a whole number. In other words, you need to end up dividing into 54 evenly. So since that happens here and I get 6, really that means that if I plug that back in, it's going to be like 12 of the solid color, and it would be 42 of the multicolor. Okay, and notice that checks because that adds up to 54. So this is going to be the correct answer, basically letter G here, 2 to 7. Just to show you real quick what would happen with some of the other ones, like if you tried to check like 3 to 2, so 3x plus 2x equals 54, what would happen is you would get 5x equals 54, and then x is going to come out to some decimal. Basically, it's going to be like, should be 10.8. And then when you plug that back in, like you multiply 3 times 10.8 and 2 times 10.8, you don't get a whole number of hamsters, which doesn't make sense. The number of hamsters for both the solid color and the multicolor has to be an integer. It has to be a whole number. And the same thing's going to happen with like J and K as well. So again, you set up basically, you take the two numbers in the ratio, just multiply them each by some number, say x, a variable, and you add them together and equal that to the total. And then solve to see which equation gives you a whole number for that multiplier, for that x value. At the bottom of the page, we have problem number 53. So this problem is actually very similar to some they had on previous tests where they had like two-way tables and charts, and there were a couple questions where it was like, what's the probability of selecting a student from this two students from the same grade at the same high school? And you have to go through like and find the probability of all the different possible scenarios and just add them together. And that's what you have to do here because it says what's the probability that both cookies you choose are of the same type. So we technically find three different probabilities and then we just add them up to get the final answer. So it's like scenario 1 or outcome 1 is, what's the probability of selecting 2 chocolate chip? So that's just going to be 5 out of 10 on the first selection and then 4 out of 9 on the second one. And then the next one is oatmeal raisin, and so that would be 3 out of 10 and then 2 out of 9. And notice the 10 drops down to 9 because you are not replacing the first cookie. And the same thing's happening on the top two. The number of favorable outcomes is reducing by 1 as well. And then the last one is sugar. So for that one, it's going to be 2 out of 10 for the first cookie, and then 1 out of 9 for the second cookie. So notice now each of these are out of 90. So I'm just going to put a common denominator down here of 90. And then for the numerators, I just end up with 20 and 6 and 2. So you just add all those together. It's really like adding 20 over 90 plus 6 over 90 plus 2 over 90. And you keep the same denominator, of course, and you just get 28 over 90. And again, these multiplications, you could just do this all on the calculator as well. You don't have to do this by hand. But correct answer for this one's going to be letter C, 28 over 90. Okay, at the bottom of the page then we have problem number 56. This problem is actually a little tricky the way that it's set up. But basically what's going on here is, so we have two people. One is going at a faster pace than the other. And after 1 hour, one person has gone 6 miles, one person's gone 4 miles. Okay. So if Bill continues at the same speed, basically to finish the 30 miles, he's got 24 miles left to go. And his current pace, notice, is 6 miles per hour because he went 6 miles right here in 1 hour. So we just divide that, the 24 miles he has left, by the 6 miles per hour. So it's going to take Bill 4 hours to complete basically the rest of this fundraising event. So that means Nate has to basically catch up to Bill in, over a total time of 4 hours. Notice that Nate so far after his first hour has completed 4 miles. So therefore, 30 miles minus 4, he's got 26 miles left. This is for Bill, and now we're talking about Nate. So he's got 26 miles left, and he has to do those 26 miles in 4 hours. So that means his average, pace, his average speed, just dividing these, is going to be 6.5 miles per hour. So that's what he has to average over the remaining, 4 hours that he has to catch up to Bill. His current speed or his current pace for the first hour is just, 4 miles per hour because he went total distance of 4 miles over total time of 1 hour. So you just subtract those, 6.5 minus 4, and we get 2.5 miles per hour as basically the difference between his speed, and he obviously needs to increase his speed because Bill is going faster than him over the first hour. So the correct answer is going to be letter J. And also notice, if you're looking through this problem, like even if you had no idea kind of how to set it up, you should be at a minimum able to eliminate answer choices F and G because he's obviously going to need to increase his speed to catch up to Bill, who is, moving at a faster pace than him or has gone a, longer distance than him just in the first hour of the event. The last problem on the test, number 60, this one is, again, a somewhat tricky problem just because of the amount of time it takes to kind of work through it. So there are multiple ways you could figure this out. The first way I'm going to show is what I think is kind of the most intuitive way or easiest way, where you're basically picking numbers. So what I did is I just let A and C each equal 2. Okay, so therefore I had an equation of 2x squared plus, and I'll get to b in a second, plus something x plus 2. Alright, then basically I chose b such that I could make a nice, easy problem that could be factored. Alright, so I let b then equal 4. So that made my equation 2x squared plus bx plus 2 equals 0. These 2, 4, and 2 all meet the conditions of the problem because all we need is that a and c are equal and that both roots are real numbers, and we'll just confirm that when we solve this, that we get our, we get real number solutions for this. So then, and I'm just going to confirm that by factoring and solving it. So first step, I'm going to factor out basically the common factor that's in both a and c, and I specifically chose b such that I could factor that same number out. So because a and c were 2, I wanted an even number for b. Now once I've done that, notice this will just easily factor into x plus 1, times x plus 1. And so therefore, when we solve this, we just get x equals -1. Basically it's a repeated root. Okay, so both roots for here are real numbers. So we met all the conditions of the problem. So now let's go through and compare all the answer choices and see which one, and hopefully it's only one, is true. So for f, a is greater than 2c. So a is 2, 2 times c is 4. Is a greater than 2c? No, eliminate it. Letter G, a equals b. Does 2 equal 4? No, it does not, eliminate it. H, a greater than or equal to 2b. Is 2 greater than or equal to 2 times 4, which is 8? No, eliminate it. J, a is greater than b. Is 2 greater than 4? No, eliminate it. So by process of elimination, it looks like it should be letter K, and in fact it is letter K, and we can just confirm that. 2 less than or equal to b, which is 4, divided by 2. So is 2 less than or equal to 2? Yes. It's not less than it, but it is equal to it. So the correct answer here is letter K. So that's what I think is the easiest way to solve the problem. Now I'll just show you technically like the theoretical way that you could have gotten the answer. So if you think about the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so it tells us in the problem both roots are real numbers. That means this part right here under the radical has to be greater than or equal to 0. So if you set up an equation, or really an inequality, to solve, okay, so b squared minus, and now here's the other thing, since a and c are equal, like I can plug in, for a I can plug in c, or for c I can plug in a. So since all these answer choices have a in it, I'm going to replace the c with an a. So this turns into minus 4a squared. Okay, and now this is greater than or equal to 0. Now, if you just go ahead and separate this, we get b squared greater than or equal to 4a squared. Now divide by 4. So we get b squared over 4 greater than or equal to a squared. And notice now if you square root both sides, you get b over 2. Square root of b squared is just b. Square root of 4 is just 2. Greater than or equal to a. And now if I just rearrange this and put the a on the left, it would be a is less than or equal to b over 2. Okay, and technically you would put like pluses and minus on both sides here, but we're just assuming, we're just working with the positive, root of it, basically. So that's how you technically could derive what the correct answer is, or derive the formula by the information they give you in the problem. But that is not what I would think is the common way to solve this problem. I think the much more common or intuitive way is to do picking numbers and just come up with an example problem, and then based on that see which of the formulas in your answer choices is true or correct.